Hello and welcome Math 140 students. We are going to pick up on page 1, section 2.1. So we're going to do a little warm-up, making sure that we know how to do these different problems that come up in our homework and in our exams and in our quizzes. So let's evaluate the expression x plus 4, but the piece of information that they give you is that x is equal to negative 3. So what that tells us is that we are going to substitute in that value. So whenever we see that x is equal to 3, we're going to plug it in to that x that we see there. So plug in the value. So when we plug in the value, we are going to have parentheses plus 4. And inside the parentheses, whenever you do a substitution, you're going to plug in that value. So now you have negative 3 plus 4. Well, negative 3 plus 4 is going to equal a positive 1. Now for number 2, it tells us to simplify. So here what we see differently are parentheses. That parentheses tells us to distribute. So we are going to multiply number times number. So we are going to get a 16n plus 4. That comes from multiplying that 4 inside the parentheses, and you still have a minus 15n. So now to combine like terms, you see that you have a 16n and a negative 15n. That means they are similar terms or like terms. So we have these like terms because they both have the expression n to it. So what we do with add terms, you can either add or subtract. So we're just going to be adding the coefficients together. So a 16n minus a 15n plus 4. So now when you have 16 minus your 15, well, that's just 16 minus 15, which is just going to give you a 1n plus 4. Now you can either write your answer as a 1n plus 4, and that's a 1 there, the number 1, or you can write your answer as just an n plus 4. You don't necessarily need that 1 in front of the n, since you can count that there's only one n. So it says translate into algebra, 5 is less than x. So that less than, to me, and most importantly, speaking the mathematical language, we are going to know that this is really meaning subtraction. If you have less than what you originally started with, you would have less, so you get less by a subtraction. You're taking away items, okay? And so when we read that 5 is less than x, well, you're actually going to write as an x subtraction, and then you have that number 5. So x minus 5 is going to be 5 is less than x. So that is going to be your answer. Now, for number 4, it says determine whether x is equal to x is equal to 1 is a solution of 4x minus 2 equal to 2x plus 1. So what this is asking you is, hey, plug in that value of x is equal to 1 into the equation. Tell me if it's a true statement or a false statement. And if you're like, okay, what's a true statement? So here, if we're trying to investigate what's a true statement, what's a false statement in mathematics, we want to see whether or not both sides match up. If both sides match up, then that is a truth. So for example, I were to have 0 is equal to 0. That would be a true statement. Each side has same value. Okay? And something is going to be false, for example, if I have both sides not equal to each other. So the opposite of that is they're not going to be equal. So for example, two numbers that are not equal is 5 and 8. I know that those two cannot be equal. That's a lie. So that's a false. So we say that each side is different than the other. So that is going to help us determine whether that value is going to be a solution of that equation. So what I'm going to do is I'm going to try to work out this problem and tell you whether it's going to be a true, which is a truth, or a false, which is going to be a lie. So if I have my 4x minus 2 is equal to 2x plus 1. Well, I know that the value that I'm plugging in is that x is equal to 1. So I have 4 parentheses minus 2 is equal to 2 parentheses plus 1. Why did we put the parentheses? We put the parentheses because that's the value for x that you're plugging in. And that value that you're plugging in is 1. So now you get to simplify each side. So 4 times parentheses 1 minus 2 is going to be a 2. Let's see what we get on the right-hand side. I have 2 parentheses 1 plus 1. That gives me a 3. So this is asking me, hey, is 2 the same value as 3? So you want to ask yourself, are these the same? Well, if I'm comparing the numbers 2 and 3, are these numbers the same? Well, your answer would be no, they're not the same. Well, since it's not the same, then we're going to be looking at false. So this is not a solution. And remember, what we had done is that we tried x equals to 1 into our equation. 4x minus 2 is equal to 2x plus 1. So when doing these problems, we are going to go step by step, okay? We're just going to get the language of mathematics. So step number 1, we want to simplify each side of the equation as much as possible. So the equation that they're talking about is the one right above. So we really want to solve for this equation. So I'm going to write it down, 7 parentheses n minus 3 minus 8 is equal to a negative 15. So when it tells us to simplify each side of the equation, then we want to distribute that 7 inside. So I have 7 times n, which is a 7n, 7 times 3, which is a 21, and you still have minus 8 is equal to a negative 15. So it's still not simplified on each side. I can still combine that negative 21 and that negative 8. So now I have 7n, and you have negative 21 minus 8, and you can use your calculator if you need to, and you have a negative 29, and you have a negative 15. So now each side of the equation is simplified. Now for step number 2, it says to collect all the variable terms on one side of the equation. So remember, from the step up above, I had that 7n minus 29 is equal to a negative 15. So now if I'm going to collect all the variable terms on one side of the equation, well, that tells me to add 29 to both sides. Okay, that's the term that are the same. So now that we're here, step number 2 says collect all variable terms on one side of the equation. So what are these variable terms? So these variable terms are all the letters in the alphabet. And in particular, if we're looking at the equation above, that letter here is n. That would be the variable. So my variable here is n. I want to make sure that they're all gathered on one side of the equal sign. And we can see if I have 7n minus 29 is equal to a negative 15, which is the exact same equation from above, we can see that that n, that variable term, is already can't combine with anything else. So we leave it alone on the left-hand side. So for number 3, or step number 3, it says collect all the constant terms. So if I'm thinking about all the constant terms, well, that would be all the numbers. So for my equation above, I have my 7n minus 29 is equal to a negative 15. So the constant number here would be a negative 29 and a negative 15. So I'm going to have to move one of them to combine it. So here, since I have a 7n minus 29, you want to isolate that variable as much as possible. So I'm going to add the 29 to both sides. That's collecting the constant terms on just one side of the equation. So now I'm going to have a 7n is equal to, and now a negative 15 plus 29, that's going to be a positive 14. For step number 4, we want to make the coefficient equal to 1. So that coefficient here would be that 7. So if I have 7n is equal to a 14, well, since I want to make that coefficient equal to a 1, I'm going to divide by the actual coefficient that I see, which is 7. So now I'm going to get that n is equal to a 14 divided by 7, which is going to be a 2. And before I circle my answer, I always want to check. Remember, we want to solve for this equation, and we also want to check the solution. So we're not sure if n equals to 2 is really a true or a false statement. So remember, we have that 7 parentheses n minus 3 minus 8 is equal to a negative 15. Well, if we want to check if n equals to 2 is going to be a solution, then that's the number that we are going to plug in. From step number 3, this is the equation simplified. So we already know that we would have a 7n So now what we're going to do is we're going to plug in that n equals to 2 value into this equation. So I have 7 parentheses, and I have that n value of 2 minus 3 minus 8 is equal to a negative 15. So if we simplify this, you can just plug it into your calculator, 7 parentheses, and you can do your parentheses again with that 2 inside of it, minus 3, close your parentheses, minus 8, and you get a negative 15. And on this side, you already had a negative 15. So you can know for a fact that both sides are equal. It checks out. So since both sides are equal, this is going to be a solution. So n equals to 2 is going to be your solution. So we come across some more examples. And again, you guys are allowed to use your calculators here. Let's just figure out what we are going to have to do. So if I have p plus 1/3 is equal to 5/6. Well, what you want to do is you want to get that p isolated. So to get that p by itself, you are going to do the opposite of addition. So since it's plus, the opposite of addition is going to be subtraction. So minus a 1/3 on both sides. So now you have p is equal to, because those cancel out, a 5/6 minus your 1/3. And if you want to get the same common denominator and do that, that's fine. Or you can bring it up on your calculator. So I have the fraction of 5 over 6 minus your fraction of 1/3. So we have 5/6 minus 1/3, which is going to equal to a 1/2. So now you know that this is going to equal a 1/2. So P equals to 1/2 is going to be your answer. And you can always check it. And for number 2, since we have subtraction, y minus that 7.2, well, the opposite of subtraction is going to be addition. So add 7.2 to both sides. That will isolate that y variable by itself. So now what you have is that 5 plus that 7.2 value, since it cancels out on this side. So 5 plus 7.2 is going to give you a 12.2. And that will be your final answer. For number 3, you can think of it as this being a -1 that's being distributed into those parentheses. So if you take that -1 and you multiply inside the parentheses, you'll get a -k minus 7 plus your 2k plus 8 is equal to 7. So here, combining like terms, you know that you have some k values and you have some constants. So you're going to rewrite this. So you have a -k plus your 2k, and you also have your -7 plus 8 is equal to a positive 7. So combining that -k plus 2k, that's going to give you a positive 1k. And you also have a -7 plus 8, which is going to give you a positive 1. So since you have 1k plus 1 is equal to 7, you want to get that k by itself. So subtract 1 from both sides. So that you have 1k is equal to 7 minus 1, which is going to be a 6. And remember, if you have 1k is equal to 6, or if you have k is equal to 6, those represent the same value since it's just 1k. Now for number 4, we have fractions. We have 3v minus 6 over 2 plus 5 is equal to 11v minus 4 over 5. So what I want to do is I can multiply by the LCD. So if I look at my denominators, if I have 2 and 5, my LCD would be a 10. So I'm going to multiply each individual term by 10. So each term, that is a term, this is a term, and that is a term. So I have my 3v minus 6 over 2. And remember, I'm multiplying by 10. So 10 over 1. And I have my plus 5. And I am multiplying by 10 is equal to my 11v minus 4 over 5. And you're multiplying by a 10. So now, since you're multiplying each individual term by 10, I can go ahead and do that. So 10 and 2, I know that I'm going to have a common factor of 5. So I have 5 times my 3v minus 6 plus, and I have my 5 plus 10, so that's 50, is equal to, and on this side I have 5 that goes into 10, that would be a 2. So I have 11v minus 4. and it's going to be multiplied by a 2. So I'm going to distribute that 5 inside to give me a 15v minus 5 times 6, which is a 30, plus your 50 is equal to, and now I'm going to multiply that 2 inside, so it'd be 22v minus, since 2 times 11 is 22, 2 times 4 is 8. Now combining like terms, I have a negative 30 plus 50, so that will give me a positive 20 is equal to a 22v minus 8. Now to combine my v terms together, I'm going to look at which one is bigger. Is 15 bigger or is 22 bigger? Well, since 22 is bigger, then I am going to subtract that 15v from both sides to make it positive. So now I have a 20 is equal to 22 minus 15, which is a 7v minus 8. So to give myself more room, I'm going to say that 20 is equal to a 7v minus 8. From here, you can add 8 to both sides, so that 28 is equal to a 7v. Well, to get that v by itself, I divide by that number to get the coefficient equal to 1. So that 28 divided by 7 is going to give me a 4. So I have 4 is equal to v as my final answer. Taking a look at number 1, we have 11 more than x is equal to 54. So that equals, remember we have is equal to. So that is going to represent your equals. So let's reread this side of the equation. 11 more than x. Well, that more than, that represents addition. So you're going to add 11 plus x. And you have your is equals to, and it tells you that it's equal to the number 54. So what you have is 11 plus x is equal to 54. So not only did I translate the equation, or that sentence, but now I also have to solve it. So I'm going to have to subtract 11 from both sides to get the x by itself. And so I have 54 minus 11, which is going to give me a 43. So I have that x is equal to a positive 43. For problem number 2, it says the Lopez family has 2 cats, Zeus and Athena. Together they weigh 23 pounds. Zeus weighs 16 pounds. How much does Athena weigh? So I am not the best cat drawer, so please, excuse my drawings. But I know I'm dealing with my 2 cats. So these are my 2 cats. So I know that one cat is called Zeus and the other cat is called Athena. I know that together they weigh 23 pounds. And Zeus weighs 16 pounds. How much does Athena weigh? So you want to know how much Athena weighs. So you want to know the weight of your cat, Athena. Well, you already are given that Zeus weighs 16 pounds, so this is 16. And if my sentence says together they weigh 23 pounds, well, that means you add them together. And when you do, it's going to equal your 23 pounds. So 16, which is Zeus. So the weight of Athena and the weight of Zeus added together is going to give you 23. But we don't know Athena's weight. We don't know how much Athena is going to weigh. So what we do is we give it a variable. So let's say that the weight of Athena is represented by my unknown. Let's call it x. So now I have a 16 plus x, which is the weight of Athena, is equal to 23. So I am going to subtract 16 from both sides. So I have that 23 minus 16 gives me a total of 7. So since x is equal to 7, well, remember it represented the weight of Athena, your cat, and so the cat weighs 7 pounds. And that will be your final answer. It reads, Ron's paycheck this week was $17.43 less than his paycheck last week. His paycheck this week was $103.76. How much was Ron's paycheck last week? I think the best way to explain this is to think about this problem as this week and last week. So we know that we are talking about this week, and we're also talking about last week. And we're going to separate these two into an equation. So it says Ron's paycheck this week, so we are here in this week, was $17.43 less than his paycheck last week. So last week we had a paycheck, and I don't know how much it is, so let's call it X. But this week the paycheck was $17.43 than that value that I had last week. Now for the second sentence, it says his paycheck this week, so we're still looking at this week, was this amount. So we know the exact amount it was for this week. But what we want to know is how much Ron's paycheck was last week. So what is the value of X? So what we have is this equation. So we know that we have X minus 17.43 is going to equal to the value of that 103.76. So now I'm going to add 17.43 to both sides. Well, I know that it cancels here, so I have X is equal to, and I have my 103.76 plus 17.43 is going to give me a value of 121.19. So I know that Ron's paycheck last week had a value of $121.19. And that is going to be my answer. Looking at number 4, it says Lucy rode her bike a total of 18 miles from home to the library and then to the beach. The distance from Lucy's house to the library is 7 miles. What is the distance from the library to the beach? So we are riding a bike, okay, and you know that the total distance is going to be my 18 miles. So I know that my total is going to be 18 because she rode a total of 18 miles. And where she's riding to is from home to the library and to the beach. So we have your home, where she starts out with. I'm doing this very quickly. So there's my home. And then from there, I'm going to go to the library. So this is going to be my road. So she's riding her bicycle and she ends up at the library. So I did this very quickly, but that's a book, if you're wondering what that was. She goes to the library, and then from there she's going to go to the beach. So she's still riding her bicycle, and she goes to the beach. So that's water, and maybe like the sun. And so that is going to represent my beach. Okay. Okay. All right. So we know that the distance from Lucy's house to the library is 7 miles. So we know that that stretch that goes from her house to the library is 7. So that tells us that this is going to be 7 miles, since it tells us. So now what we're trying to figure out is the distance between the library and the beach. So this is what we don't know. But we also know something else. We know that the total is equal to 18. So what we have is we have 7 miles plus I don't know the distance between the library and the beach, but I know that the total miles that she rode on her bicycle was 18. So for that question mark, we can say it's 7 plus x is equal to 18. So now I have a -7 to both sides, and I'm going to have a 18 minus 7, and that's going to equal to 11. So I know that she rode, and this is Lucy. We want to know the distance between the library to the beach. So Lucy rode 11 miles from library to the beach. So that is what I have. And so my answer is 11 miles, and that is the end of section 2.1.